Hello everyone, welcome to my YouTube channel. Today I'm going to be solving a question based on the concept of Newton's laws of motion and resolution of vectors. Now let me read out the question first. Block on a plane is the concept. A block sits on a plane that is inclined angle theta, so it's an inclined plane with an angle theta with a horizontal surface, and the block is placed on that, let's say, of mass m. Let me draw the diagram first. Assume that the frictional force is large enough to keep the block at rest. What are the horizontal components of friction and normal force acting on the block? For what value are these horizontal components maximum? So let me draw the forces first acting on the body. We have a force of mg acting downwards. Normal force is always perpendicular to the two surfaces which in contact, that is, like that m is in contact with the inclined plane, so it is perpendicular to the inclined surface. The normal force is acting on the body of mass m. Now this is the force diagram on the body of mass m, not on the inclined plane, and now there is a frictional force like this, and this is theta. We know this is 90 degree. Let me draw the diagram more clearly. This is theta, this is mg downwards, and this is the direction in which normal force act 90 degree. And we know this is 90 degree because the horizontal surface is perpendicular to the vertical surface. So this will be 90 minus theta, and this angle is theta. So mg makes an angle of theta, the line in which the normal force is acting. So it makes an angle theta with the line in which the normal force is acting. So if we resolve it in the direction, we get it as mg cos theta. And if we resolve another force in the direction of the friction force, that is, it will come out as mg sin theta in the direction in which the inclined plane is there. So the force acting on the body of mass m, as I have shown, is mg sin theta downwards, frictional force, normal force, and mg cos theta. Since the block is at rest and friction force is large enough, so friction force here is mg sin theta, since friction is an adjusting force according to the external force. Now, and normal force is equal to mg cos theta. Now how to find out their horizontal components? So let's draw the diagram again from first. Friction is mg sin theta and normal force is mg cos theta. Now frictional force is like this and normal force is like this. Let's forget about the other forces. Now if I extend this line, we know this angle is 90 degrees, since it makes an angle 90 degree with the inclined plane. Now, so this angle should be 90 minus theta. If I draw a parallel line, that a line that is parallel to the horizontal surface, we know these two are alternate interior angles, so this angle also should be 90 minus theta. And we know the frictional force is perpendicular to the normal force, so the direction in which friction is acting should be perpendicular to the direction in which the normal force is acting. So this total angle should be 90, so therefore this should be theta. So therefore this should be theta. Now resolving friction in the horizontal direction will be f cos theta. Now finding the horizontal component of normal force, how do we do it? We just draw another line like this, and we know these two are alternate interior angles, so this will be theta, this will be theta. And now this normal force makes an angle 90 degree with the direction of in which the inclined surface is, so therefore this angle should be 90 minus theta. N cos 90 minus theta is n sin theta. N sin theta is horizontal component of normal force, and f cos theta is the horizontal component of frictional force. You know, frictional force is mg sin theta as we have calculated. Then only the block will be at rest. Similarly, normal force is mg cos theta. So normal force horizontal should be mg sin theta cos theta. Now how do we find the maximum value of these horizontal components? For what value theta? We know that mg sin theta cos theta can be written as mg sin 2 theta by 2, because 2 sin theta cos theta is equal to sine 2 theta. We know sine 2 theta is maximum when theta is equal to 45 degree. Why? Because sine of 90 degree is equal to 1, which is the maximum value of a sine function. So therefore the value of the horizontal components will be maximum when theta is equal to 45 degree, and the value of the maximum horizontal component of normal force and frictional force will be mg by 2. Thank you. Please like, share and subscribe.